All right, Math 5130, more on logistic regression. As tempting and as much as I would enjoy diving more into the mathematics of logistic regression, that's not what you need. You just need to see how you would need to run one of these models if you have a situation where you have a dependent variable that's dichotomous and you want to have some predictors that you want to create a logistic regression model. So what I'll do in this video is I'm going to predict fall status from cane use, age, and react time. I have no idea where this is headed. I don't know whether we're going to get a good model or a bad model, but you never do. So it kind of mirrors reality. So first thing we would want to do is I noticed that I have fall status and cane use. Both of these are categorical. So first thing I'm going to do is I'm just going to rename fall status as fall, and because it's easier to type than fall status, and I'm going to force it as a factor, which I have to do. Next thing I'm going to do is the same thing, but I'm going to just rename cane as something easier to type, just lowercase cane. The next thing I have to do, again, because I'm now forcing these things into dummy variables, is I need the reference group to be clearly specified. So I'm just going to re-level fall back into itself with the reference category as none. I'm going to re-level cane back into itself with the reference category equal to no. Now, notice that the reference category is a level, categorical. I have to put this in quotation marks, so just make sure. So what did I do wrong? No, I misspelled re-level. Okay, well, kind of glad that happened. That re-level. Alrighty, so successfully done now. All right, so let's run our model. So we use the GLM command. Our dependent variable here is fall, and the predictors are age and cane use and react time. Remember to I did that last time, didn't I? To run a general linear model, logistic regression, I have to add family equal binomial. Now, to get a summary of our model, I just go summary model, and I want to go through every single bit of this and tell you what this all means. First thing we do is we just call the formula. Next thing we do is we get into what are called the deviance residuals. I'm not going to get into that, but it's just a residual is just a measurement of error. We call those deviance residuals. You can see the residual deviance down here given on the degrees of freedom. We'll use that in just a second for a model diagnostic. The next thing we get into is we get into the coefficient. And, I think it's just natural to have tunnel vision to go directly to the p-value line. We can see that we have nothing statistically significant here. So none of the predictors are statistically significant individually in predicting fall status. Now, remember, the estimates deal with like the legit of something. We don't need to go there. We need to know that to make this into odds language, we have to take the EXP of the estimates. So for age, I need the EXP of negative 0.03106. Okay, so to interpret that, let me put the hashtag here. I would say controlling for the other two models, or the other two variables. Wait, that was age, wasn't it? Okay. Controlling for cane use and react time. As age increases 1 unit, the odds of falling increases 0.969. So some of this should kind of remind you of multiple regression, where we have a quantitative dependent variable controlling for, yeah, that's been consistent, just controlling for the other two variables. And remember, this EXP analyzes odds ratio. So because we have an independent variable that is quantitative, we go back into this as it increases 1 unit, just like we did with multiple regression. But instead of a predicted value, we are predicting the odds. So I would come in for cane use, so 0.43962 is 1.55. So as you might imagine, I would say controlling for age and react time. The odds of falling are 1.55 times higher when using a cane versus not using a cane. It's the way we categorized or set the level for cane use. So it's super, super important in categorical variables that you understand the reference of what you're comparing to. And again, cane use, I said the reference is no, so I'm comparing cane use to non-cane use. That's why I say cane use versus non-cane use. If I had tested or set cane use as a reference of yes, then this value right here would be the times higher for not cane use versus cane use. So super important. I'm not going to type out react, but I would still negative 0.01779. So the odds are 0.98. So I would say controlling for age and cane use. As react increases 1 unit, the odds of falling are increases 0.982. Now, the next thing we get into, and significance levels. Again, I want to go through every single line so you understand what's happening here. Dispersion parameter for binomial, don't worry about that. And the convergence, it took 4 scoring iterations for this model to converge. Don't worry about that. You'll report it, as you'll find out in a later video, but don't worry about that. So the next thing we get into is this right here, and this is the model diagnostic. So the model diagnostic takes a little bit of work on our end, and we need to take, first of all, the difference in the null deviance and the residual deviance. So I need to calculate that. So 330.99 minus the residual deviance, which is 326.37. So the difference in the deviances here is 4.62. The degrees of freedom have a difference of 243 to 240, so they have a difference of 3. Now what I do here is I use the chi-square distribution to calculate the p-value. So the p-value for the chi-square distribution, it's actually probability of chi-square distribution. I put in the difference, and then I put in the difference of the degrees of freedom. So I'm going to put 243 minus 240 there. So in your notes, it's going to be clear. Now the p-value is 0.201, actually 0.202. That is greater than 0.05. So we conclude that our model, the set of predictors, age, cane use, and react are not significant predictors in determining, predicting falls versus non-falls. So for this model deviance down here, the well, let's use this. The H sub O is our set of predictors do not distinguish between fallers and non-fallers. And our H sub A would be our set of predictors distinguish between fallers and non-fallers. All right, so that's the null and alternative hypothesis. Again, being consistent throughout the class. If we have a p-value, context is super, super, super important. All right, so I guess that takes care of just about everything that, oh, let me explain one more thing, AIC. AIC is a Kayake information criteria. It's developed by a great statistician, Kayake, out of Japan. 334.37 means nothing in isolation of another AIC, but an AIC gives us a metric for model comparison. So if we have two models and we'd like to compare whether one model is a statistically significant improvement over the other, we can analyze the AICs. And it turns out if the AICs go down, then we have a model improvement. So you'll see on StatCrunch that they have a different model diagnostic, and that's where I'll go next. I'll demonstrate all this in StatCrunch. I hope this helps. Logistic regression is always a little bit more challenging than multiple regression.